All right, chatting about geometric sequences. If we look at these patterns, we just look at pattern number 1, determine whether the sequence is geometric or not. If it is, identify the common ratio and give the next 3 terms. And I'll tell you right now that number 1, yes, is a geometric sequence. So, what is a geometric sequence? It's basically a multiplying sequence. And just like with an arithmetic sequence, you have to multiply by the same thing every time. You can't multiply by 1 and then multiply by 2 and then multiply by 3. It has to be times 2, times 2, times 2, times 2 every single time. And that's what's going on here. This is a times 2, times 2, times 2. And so we don't call that the difference anymore because it's not the difference between these two numbers. It's technically the ratio. And so we're going to use R equals 2. Notice that the second number is twice as big. The second number is twice as big. The second number is twice as big. Even though the actual difference here, there's a difference of 6 and then a difference of 12 and then a difference of 24. So we're not calling it a difference anymore. We're calling it a ratio. And then to give the next 3 terms, we would just continue multiplying by 2, which again, if you have a calculator, is easy. 96, comma, 192, comma, 384. Sure. So let's go up and let's write this down, right? This is a pattern where we multiply by the same thing over and over again. Right? And again, importantly, it has to be the same number. It has to be the same number. Our common ratio is that number that we multiply by. Terrible handwriting, but whatever. Number that we multiply by. So that's easy for number 1. Jumping to number 3. Number 3, the numbers go -2, +10, -50, +250. Are we multiplying by the same thing over and over and over again? How do you go from -2 and get to +10? What are we multiplying by right here? So we're on this one here. -5. Nice job, Devin. Multiplying by -5. Does that work again? Can we get times -5 to get to -50? Does that work again to get from -50 to +250? Yes. So our ratio can be a negative number. If it is a negative number, notice that when you have a repeated multiplication of a negative number, you're going to go positive, negative, positive, negative, positive, negative. So if you ever see a pattern that goes positive, negative, positive, negative, positive, negative, you automatically know it's going to be geometric. You automatically know that the ratio is going to be negative. To come up with the next couple terms, I mean, we don't have the time to do this, right? I mean, negative 1250, blah, blah, blah. The next one would be a positive number. The one after that would be a negative number. Whatever. We don't have a calculator. Let's just move on. Now, we skip number 2. Number 2 is a positive number, a positive number, a positive number, a positive number. So it's not a negative ratio. It is a geometric. What would our ratio be? Something with a 3, right? So that's a really good thought. Why'd you pick 3? So you picked 3 because going this way, times 3, times 3, times 3. I mean, all these numbers are screaming 3s at us. But it can't be 3 Because if our ratio is 3, we should be doing times 3 times 3. And we're going down instead of going up. So, anybody, it is something with a 3. Anybody got to guess how it would look? So with addition, we had positive numbers would make us go up. Our pattern would be increasing. A negative number would make us go down. With multiplication, it doesn't quite work that way because our negative numbers are just flopping our signs. What do you say? It's good thoughts. It's good thoughts. Basically, would you agree that we are dividing by 3, right? We are dividing by 3, right? Now, here's the thing. The ratio is what we are multiplying by. So we can't put divide by 3 as a ratio. So let's do this strategy, okay? Second, first, when we were doing difference and we wanted to find how much are we adding, we did the second minus the first. So if we want to find out how much are we multiplying by, we should do second divided by the first, okay? Because we're trying to kind of unwrap it. So second divided by the first will always tell you the ratio. And I'll tell you this, when it comes to arithmetic, you guys can pretty much figure out the difference every single time. When it comes to the ratio, you're going to need to know this because some of the ratios are tricky to find. Some of the ratios can be a bit nasty. So if I'm going to do second divided by first, I can just do it in Desmos here. Second divided by first. It's going to give me a decimal, and I can even press this button here, if you remember from last week, turn it into a fraction. And so our ratio would be 1/3. And the short answer there is if you're dividing by 3, then the ratio is 1/3. If you're dividing by 2, the ratio is 1/2. I mean, just think about it like this. Like, how does this number compare to the number before it? It is 1/3 as big. Yeah. Now, what would come next? 10 would come after 30, and then 10 over 3, because we're basically just dividing by 3. And then 10 over 9, because we're just dividing by 3 over and over again. Number 4. What do we think about number 4? This looks like a times 2. This, ew. This looks like a 2.5. This looks like we're multiplying by 5 halves, maybe. Yeah, that's not the same. No, it's not geometric. We have to multiply by the same number every single time. Okay, what about number 5? Well, if you're never sure, you can always just do this. Take the second number and divide it by the first. So we could do, and this might seem a little silly, we could always do -1 divided by 4, and it would tell us that our ratio is -1/4. So if our ratio is -1/4, does that continue? Are we getting -1/4 should be flipping our sign, should be getting 1/4 as big. -1/4 should be flipping our sign, should be getting 1/4 as big. -1/4 should be flipping our sign, getting 1/4 as big. So again, you're going to need this rule. If you've got highlighters, do it. If you want to do one of these, do it. You're going to want to use that rule to help you find the ratios. They can be tricky for sure. And again, what numbers would come next? It would be positive number this time, 1/64. It would be a negative number this time, -1/256. It would be a positive number this time, 1/1024. Whatever, who cares? Use a calculator, easy. Number 6. This looks like a times 2. What do you say? Right, so this is a pattern. 2 squared makes 4. 4 squared makes 16. 16 squared makes 256. But is that a geometric pattern where we multiply by the same exact thing? No, right? This is a times 2, and then this is a times 4. And right there, you know, it is not a geometric pattern. No. What would our ratio be for this question? It looks like 7. Now, we probably want to make sure. I know that we're multiplying by 7 here. We probably, you know, I don't know that 14 times 70 is 98 off the top of my head. So I would probably just come in here. I would do negative 14 times 7. Yeah, I can't do that. I got to pull this up. Wave times 7, negative 98. Okay, cool. Happy with that. My ratio would be 7. What are these numbers going to be? Whatever. Do it in a calculator. We'll figure that out later. Now let's look at number 8. I don't really like number 8. I mean, okay, let me say this right. I like as a teacher, I like number 8. As a student, I don't know that I like number 8 because none of these numbers are kind of looking like multiples, right? 8 times 1 would be 8. 2 would be 16. 3 would be 64. Sorry. 3 would be 24. Going absolutely crazy. So I don't know how to get from 8 to 20. It's not 2 because 2 would be 16. It's not 3 because that would be 24. So it's going to have to be some kind of fraction to get from 8 to 20. So maybe it is a fraction. Like, even though that's not nice, we still have to check. Second divided by first, that would be 8 divided by 3.2. I'm getting 2.5, or I'm getting 5 halves as a ratio here. Now, I'm not sure that that works. You know, that's how we get from the first to the second, but let's make sure that that works, right? So we would want to do, you know, 8 times 2.5 gives us 20. So that's good. 20 times 2.5. Oh, 2.5. Oh. There we go. Gives us 50. So 2.5 is the way that we find the pattern. So again, use this second divided by first strategy. Okay, use it, use it, use it. All right. Now the geometric sequence formula is going to sound very familiar. Okay, it's going to be term 1. Nope. Term n, I forgot to start there, is going to be the first number. Instead of being added the difference a whole bunch of times, it needs to be multiplied by the ratio a whole bunch of times. Now, how do you do a repeated multiplication? You do it with exponents. So it should look like the first number times the ratio to the power of n minus 1. And that will make that ratio happen over and over and over again. We know that the a1 is the first term. We know that r is the ratio. And so find the rule for the sequence and find a to the power of 6. Okay, so, well, our ratio here would be 5. That's pretty obvious. Times 5, times 5, times 5. What would a to the power of 6 be? You know, to be honest, we're already, sorry. What would the term 6 be? It's not a to the power of 6. That was not very good for me. The sixth term would be, if I'm already at number 4, I could just do times 5 times 5. I could be done in pretty quick. But let's use our formula, even though, you know, it's probably a good idea just to multiply by 5 twice. Term 6 would be the first term, which is 1, times the ratio, which is 5, to the power of 5 minus 1. Nope. 6 minus 1, which is 5. I'm just absolutely losing it on this question. Doing a bad job. 1 times 5 to the power of 6 minus 1. Go back to Desmos. 1 times 5 to the power of 6 minus 1. Now we got some problems here. If I try to do 6 minus 1, it's not going to do it for me. It's going to put that minus 1 as like a k value. So remember, you got to go up in the exponent and do some parentheses. 6 minus 1. But make sure you get 3125 as your answer. Let's do one more question. Let's do number 10 here. We're going down, which means we're going to have a fraction as our ratio. And just to be careful, if I do second divided by first, I've said the wrong thing so many times. Oh, go away. Second divided by first, I'm going to get 0.5, just like you said, 1/2. Obvious 1/2. And again, if it wants the 6th term, you could just keep going and figure out what it would be. But to use our formula, the formula would be the 6th term is the first term times the ratio to the power of 6 minus 1. So that would be the first term times the ratio to the power of 6 minus 1. Turn it into a fraction. I got 65 over 16 if I make it a fraction. All right. Now let's move on. Let's get here. Use the information to find the value. If I know the first term is 7 and I know my ratio is 4, what would the 8th term be? So I know it goes 7 and then just needs to start multiplying by 8. Sorry, multiplying by 4, and I want to get to the 8th term. I've said the wrong thing so many times. I'm going crazy. 28. 28 times 4 would be 112. And I could just keep multiplying by 4. But I could also use my formula. Okay, I could also say, you know, a to the power of 8 should be first term times ratio to the power of 8 minus 1. That would be 7 times 4 to the power of, parentheses, 8 minus 1. And I got 114688. 114688. So it depends. A number like this, totally legit. I could give you a number like this. A number like 20 billion, probably a little too high. Okay? Like 5-digit number, 6-digit number, 7-digit number, reasonable. Oh, yeah. So for an arithmetic sequence, the numbers don't get out of hand very fast. So on an arithmetic sequence question, you might see what's term 95. Term 95 in this pattern would be a quadrillion, billion, million. So don't worry about that. However, the answer might be a high number for sure. We even might have to deal with an interesting question like this. Okay, we've got blank for first number, second term, third term, fourth term, fifth term. With a ratio of negative 1/2. So I know that this would be a positive number and then a negative number and then a positive number and then a negative number. Because I know that if my ratio is a negative number, I'm going to be flip-flopping signs. If I'm doing half as big, half as big, half as big, half as big, and I want to now look in the opposite direction, before I was negative 68, I had to have been twice as big as that because I got chopped in half. And so twice of that would be 136, right? And then, again, this works now because half of 136 makes 68. So if I'm going backwards, instead of doing a multiply by 1/2, I could do a divided by 1/2, which would basically times me by 2. We could go into Desmos and just do this a couple more times. Again, some teachers might tell you to use the formula. Okay, the formula would be a to the power of n is equal to a1 times r to the power n minus 1, and to plug this stuff in. Now that we actually can tell that's a 5, this is going to be an easy question. A1 is what we don't know. The ratio is -1/2, and the n is 5, so that would be 5 minus 1. So if we wanted to solve for A1 here, we could do -1/2 to the power of 4. In the question, it says it at the top. -1/2 to the power of 4, which is -1/16. And then we could take that. If this is -1/16, if that's -1/16, we need to divide that over to this side. So that would be -68 divided by -1/16. -68 divided by -1/16. And the answer should be 1,088. I messed it up again. Oh, I did mess this up. Should have looked like this, which would make it a positive 1/16. So yeah, we knew it needed to be a negative number because we knew that it should be flipping signs, and we had already put the negative there. Man, hope you're having a good Monday morning because I'm messing up a few times in these questions. All right. Now we might even get a question that has to do with some real world stuff. This is the very last question we're doing. Jackson brought a brand new car for $38,000. If the car depreciates in value by 20% each year, what will the car be worth in 8 years? So cars get cheaper over time. That's why you can go and buy a 2005 Corolla for however much you want to spend on it. So if he's going to start with 38,000, that's kind of like our first term. That's where we're going to start. And then this 20% each year is how much the car is depreciating. So we're going down 20% each year. Now, here's the deal. This is a really tricky question that I wouldn't put on my test because this is way too hard. If your car is worth 20% less, that actually means it's worth 80% what it used to be worth, right? See, a lot of students would say that our ratio would be like 0.2 because they would say, you know, we're 20%. But that means that we're going to be like making our number from this into 20% of this. But actually, we need our ratio to be 0.80 because we need to be 80% of what we were worth. Again, I don't think, this question in my mind is much harder than what I'd use on the test. But if we use a 0.8 ratio, that means that our car is going to be worth 80% year after year. And so now every year we can multiply it by 0.8 and figure out what it's worth. So one method that I could use is I could go and I could start with 38,000. And I could multiply it by 0.8. And I could say that after the first year, my car is worth $30,400. And then I could multiply again by 0.8. And after the second year, it's worth 24. And then multiply it again. And after the third year, it's worth 19 point, blah, blah, blah. And I could figure out that way. Or I could use my formula. My formula would say that after the 8th year, my car should be worth the first term times the ratio, which we've decided is 0.8, to the power of 8 minus 1. And so to use my formula, that would be 38 times 0.8, the power of, parentheses, 8 minus 1. So after 8 years, according to this, somewhat random question here, allegedly after 8 years, if my car is only worth 80% what it was the year before, my $38,000 car has gone all the way down to under $8,000, which is a heartbreaker, right? And it's basically saying you've lost 30 grand in 8 years. Cars hurt when the time you're buying nice cars, man. Oof. So there we go. I guess I should remember what number it says. 7969.18. Since we're dealing with money, we only need to talk about the pennies. That's good enough. Anyways, really not too bad. Not too much stuff that we've learned today, okay? We've learned you got arithmetic and geometric. Arithmetic means add. Geometric means multiply. We've learned that you have these little a's, which are talking about the terms. You've got difference, which is how much you're adding by every time. You've got ratio, which is how much you're multiplying by every time. Remember that if your pattern is going down with subtraction, your difference is going to be negative. Remember that if your ratio is going down with division, you're going to use a fraction ratio, right? So for example, right here, we were going down, so we needed a fraction ratio. We talked about how you can do second minus first to find the difference, or second divided by first to find the ratio. And that second divided by first is something you definitely want to keep in mind, because finding these ratios is really tough. You might want to put second divided by first tells you what the ratio is. I guess we forgot to kind of write that there. Second divided by first tells you the ratio. Anyways, that is arithmetic, geometric sequences. That's the whole thing. That's as hard as it gets.